Hi everybody, welcome to the last video in course Algebra. Binomial expansion. So in this case, we will find the expansion of those binomial. Bi mean 2, so there will be 2 terms. The power. Right, if it go to the 0 power, everything to 0 power is 1. Everything to first power is itself. So just a plus b square. Just multiply it out. Multiply by itself. A square plus ab plus ab plus b square, a square, b square to ab, right? And the third power and so on. Now notice when we write like this, we see the coefficient. The coefficient we stack up in what we call the Pascal triangle. One on the middle top, and then 1 and 1, and then 1, 2, 1, 1, 3, 3, 1. So Pascal triangle is the triangle. In this case, the number whatever number below is equal to the sum of the top 2 number above it. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 3 plus 3 is 6, and then so on. So we see that this can go on forever, and whatever the power is, we corresponding to the number that is the first number that is not equal to 1. So if it's to the second power, it's going to be 2, and the third power is going to be 3, and so on. So this is a Pascal triangle. So it's nice to know that will give us all the coefficient, and then what we see here is the term a, the power of a decreasing 3, 2, 1, 0. The power of b is increasing 0, 1, 2, 3, and then the coefficient. So there will be 3 components. The first term power decreasing, the second term power increasing, and then the coefficient. By the way, the Pascal triangle is nice and all, but what if we want this on the 10 line? Well, that we have to use what we call the combination of n of r times n. For example, if you look at this term, for example, if we start from r equal to 0, r equal to 1, always start from 0, 0, 1, r equal to 2. So now we have 2. And we will start on this line. We see the 5, right? The first number that is not 1. So we're going to have 5 and 2. The formula is this. 5 factorial over 2 factorial and 5 minus 2 factorial. So 5 factorial over 2 times 3 factorial is 6. 5 factorial is 120 divided by 12 is equal to 10. Right, so that's how it works. So again, n is the first number that is not equal to 1 on the Pascal triangle, and r is the term. But remember, we're counting from 0, not counting from 1. Right. The formula for that we enter in the calculator in this form. So math option, go to probability, option number 3. That ends your, but we need to enter 5, the number first, and then math. Right, so that's what we have. So that take care of the coefficient. Right, once again, that only the coefficient. Now, binomial expansion, we have 3 components. The first term is power decreasing from 3, from whatever that is. So I will say 2x. This is the first component. Start from 3, 2, 1, and 0. First term decreasing binomial, so we have going to have two terms. The second term is the negative y. Take the sign with it from 0, 1, 2, and 3. And then the coefficient. Let's just use this form instead. There are 3 of them, right? We count from 0, 1, 2, and 3. Right? And the rest is easy. Just write out 2x to the third power, ax cubed, 4x squared, 2x, anything to 0 power is 1. Next, anything to 0 power is 1, negative y, negative y times negative y is y squared, negative y cubed. Now the coefficient. So we're going to pick 0 out of 3, pick 1 out of 3. So I'm just going to do this. 3, math, probability, option number 3. And you see this button here. I'm going to do 0, 1, 2, and 3. Close curly bracket, second parentheses. Right, so that's what we have. And so the coefficient is 1, 3, 1, 1, 3, 3, 1, sorry. Which is 1, 3, 3, 1 in the Pascal triangle. Right, so those are the 3 components. And just multiply, so that gives us ax cubed minus 12 x squared y plus 6, because that's positive, 6 x y squared minus y cubed. So it's easy as that. 3 components. The first power is decreasing, the second power is increasing in power, and then the combination to get the coefficient. Right, next we have this. So the first term starting from that power and decreasing, the second term is this is plus, so I just say y squared starting from 0, 1, just counting pretty much, 2, 3, and 4. And then the coefficient for C0, for C1, for C2, for C3, and for C4. Right, now just do the math here. X to the 4th, x cubed, x squared, x, and 1. Now to the 0 power is 1, y squared, multiply the power together, y to the 4th, y to the 6th, y to the 8th. Now the coefficient for math, probability, and then second parentheses 0, 1, 2, 3, and 4. Close the curly bracket. That's what we have. 1, 4, 6, 4, and 1, which is of course what we have for the from the Pascal triangle, this line. Right, and then multiply in columns. X to the fourth, 4 x cubed y squared, that's positive, so plus 6 x squared y to the fourth, 4 x y to the sixth, and y to the 8. Well, simple enough, right? So I have 3 components. The first component start from that power and decreasing. The second component, this time is -3 from 0 power and increasing. Then the coefficient. If we look in the Pascal triangle, will be 1, 5, 10, 10, 5, 1, I think. Of course, we can also use the calculator. 5, math, probability, NCR, open curly bracket. We start from 0, 1, 2, 3, 4, 5, and close. One, to separate in column. 1, 5, 10, 10, 5, and 1. One thing about the Pascal triangle is symmetric. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So it is symmetric. The coefficient is symmetric. Make sure the coefficient of the binomial coefficient. I'm not talking about this. We might have something else common numbers there too. Right. 2 to the fifth is 32. X to the fifth, 16. X to the fourth, ax cubed, 4x squared, 2x, and 1. Now just increasing power. 1, -3, 9, -27, 81, and -243. Right? And then multiply by column. 32x to the fifth. 8 times 6, 16 times 3 times 5. 240. That is -240. X to the fourth. That's 720. X cubed, which is positive. 8 times 9, 72 times 10. And then 4 times 27 times 10. 1080. And that is -1080 x squared. And 2 times 5, 10 times 81, so 810 x positive. And finally -243. Right, so it's simple enough, right? The first term, the power is decreasing from n. The second term is the power increasing from 0 to n. And then the coefficient come from the combination. We can use Pascal triangle or we use the calculator. Alright, so that's nice and all. But what if we just want a particular term? Well, that's easy. Again, it's always 2x starting from n, the first term, start from n and go down to 0. But this time we want the fourth term, right? So the fourth term, so we just count 7, 6, 5, 4. 7, 6, 5, 4. So this is the fourth term. If we don't want that, there's another way to do this too. The second term is y, right? We count from 0, 0, 1, 2, and 3. It's much better to count the second term because we go from 0 to 4, it's going to be 1 less. We're going to do that for the next one. You will see. But it's going to be in this column. The coefficient though. 0, 1, and 3, right? So everything in this column, that's what we focus on. So that gives us 16x to the 4th y cubed. And what is that? 7 meh. Option number 3. I mean, to 3. That's 35. So 35 times 16. 560. So we have 560 x to the 4th y cubed. So that is the fourth term of that expansion. Right? We just count the fourth term. Now, the better way to count is we count only the second term, because we always go from 0. So if it is the fourth term, we stop at 3. If this is the seventh term, we're going to stop at 6. It's always one less than that if we count from 0, right? Now, notice the number here and there always the same, because we both count from 0, 0, 0, 1, 1, 2, 2, 3, 3. So those numbers will be the same. And then this number, 1 is decreasing, 1 is increasing. So those numbers always add up to n. So 7 plus 0, 6 plus 1, 5 plus 2, 3 plus 4, 7. All 7, right? How did that help? Well, let's look at this. We have x cubed. We know the power counting from 10. So x cubed, sorry. 9, x cubed, 8, and all the way down to the 7. Of course, 10, 9, 7. Of course, we can 10, 9, 8. We can do that. But it would be better just count from the second term. 0. Since we count from 0, the seventh term is going to be to the 6. And because of that, this is 10. We count from 0 again. The seventh term, we're going to have 6 as well. Those numbers will be the same. And finally, go back to the first term. The first component, the power have to add up to 10. So this will be 4. Right? Of course, we can count 10, 9, 8, 7, 6, 5, and 4. That's 7 terms. X to the 4th power. Right, and with that, that will be easy. X cubed to the 4th, multiply the exponents. X to the 12. Negative 2 to the 6th, that will be 64. Y to the 6th. And 10. That's 210. Multiply all of that. So 210 times 64 is 13,440. We have x to the 12 and y to the 6. Right, so of course we can derive the formula for that too, but as always, I said, if it is better to do the problem without the formula than with the formula. Intuitively, it's always better than relying on the formula. Once again, there are three components. The first one, the power is decreasing. The second component, the power is increasing. And then the coefficients is the combination. We can use the Pascal triangle or use the calculator. If we have to count to a particular term of the expansion, it's better to count the second component because we count from 0. Since this is 7th term, it's going to be 1 less. And the coefficient is going to have the same number. And the power of the components always add up to 10. Always add up to n. In this case, 10. So 10 plus 0, 10, 9 plus 1, 8 plus 2, and in this case, 4 plus 6. And then evaluate each term. Just be mindful that exponent, so we multiply the exponent together, and finally multiply everything in the column. That's what we have. Now, with that, we finish everything I want to cover in this section and everything I want to cover in this course. Thank you for watching.